Hello everyone, and thank you for joining us on our video series on Python for data science. Today in this video we are going to see how we can read a CSV file in Python using Pandas. We are going to take a look at different ways of reading the same CSV file. So we are going to look at 16 examples of reading the same CSV file. So let's get started. So I have a CSV file called customers located in this location on my local system, and it's a simple file. So if we take a look at the data in the file, there is a header row and you have got 4 data rows. So if you want to read this file, the very first step is to import the pandas library. So I'm just going to write the simple import command, import pandas as pd. Now the next step to read this file is to read the contents of the file and store them in a data frame. So I'm just going to call it df is equal to, and the command that we can use here is read underscore CSV. So pd dot read underscore CSV. Now since this is located on my local system, I'm going to provide the path of my local system right here. So if you go back and I copy this path right here, I'm just going to copy this path right over here, and then I'm going to try to read this file. So I'm just going have just copied the file. I have to add the file name, so which is customers.csv right here, and now I'm going to see if I can run this file. Now you can see that I've got an error message here. So there's something like Unicode escape, cannot decode bytes in position 2, 3, some kind of error message. And why this has come is because Python interprets these backslashes as special characters. So it interprets it in a different way. Now to make it interpret the backslashes as actual backslashes, we have to ask Python to treat this as a raw string. So to do that, what you need to do is simply add an R over here, and if you now try to read this, there won't be any error, which means that the commands of the file are now in this data frame, and now we can play with this file as is. Now to see what are the contents of this data frame, you can use a simple printdf command, and all the contents will be displayed right over here. So you can see that the first record, which is the header record, has been displayed as it is. You have your 4 other records as well, and then you can see that an index column has been added, and the index starts with 0, 1, 2 and 3. So the row number, it is starting reading row numbers from zeros. So this is what we need to keep in mind for further examples that we're going to explore. Now here we have read the file with a header. Let's say that we don't have a header in the file, so we want to consider this first record as a data record and not as a header. So what can be done in that case? So again, I'm going to use this imp command over here. I'm just going to copy this and keep on adding some options over here. So now what I can do is, the only thing I need to do is add the option of header equal to none. And now if I read this, you can see that again I've got an error message. Now why has this error message appeared is because Python is case sensitive, so we have to be very careful with all these things. So instead of writing none all in lower caps, what we need to do is put a capital N, and then we can write the remaining string in lower caps. So we have to be very careful with these things in Python. If you write this, it is not going to give you any error and it should be okay. I'm just going to print it again. And here what you will see that it has created an index header on its own, and the first header, the first record in our CSV file has been treated as a data record. So this can be done. There are many cases in which you will not be having any header in your file, so this option can be used in those cases. Now let's just assume that this was actually a data record, and now we wanted to add a header to this file. So we wanted to define the header names, header column names in this file. So in that case, what we can do is we can just again copy this whole command and say names is equal to square brackets, and then you have to start giving the name. So the first name I'm going to give is ID. It has to be within double quotes. The second name I'm going to give is FN for first name, and the last name I'm going to give is LN for last name. Okay, so this is what we need to do. If we just need to run this command, And if I do a printdf again, what you will see is that the column names have been given, the header column names have been given as id, fn, ln. So this is one scenario. Now there might be a scenario like it is actually in a case that there is actually a header record. Now I do not want to consider those header names. I want to give the header names of my own. So using the read CSV command, how we can do this is we can specify that we want to skip the header record. So we want to skip the first row and then we can add a column name. Now there are other ways of doing this as well, but we are going to see how we can do this using the read CSV command. Now I'm going to specify my names as I just specified above here. But before that, what I'm going to say is I'm going to say skip rows equal to 1, and then I'm going to give my names as I gave in the command above. So I'm asking it to skip the first row. So let's see which row it is going to skip, and then we are going to add the command names to it. So, and now you will see that the first row, skip rows equal to 1, which means basically skip the top first row. So it has skipped the top first row, which is customer ID, first name, last name, and it has only considered the data, the actual data records, and it has added the column header names as per our requirement. Now, the next scenario that we're going to consider is that there might be a requirement where I do not need to read all the columns in my CSV file. So how we can define that is by adding the option called use calls equal to square brackets, and then you define which columns you want to use. So I want to use the first name and last name. And if I do a printdf, you would see that the customer ID in this case has not been read, only the first name and the last name has been read. Now the next scenario is based on the column indexes that Python generates. So if we go above and take a look over here, you will see that in this case, Python had generated its own column indexes 0, 1, and 2. So instead of specifying the column names, specific column names that I want to read, I can also read by column index. So I can say that just read columns 1 and 2, and it should be giving me only the first name and the last name. So here I'm going to use the same use calls, but instead of specifying the column names, I'm going to specify the index. So I'm going to say 1, 2, and it's going to read all those 2 columns. So you can see that the result is the same as we obtained above, and it has read only those 2 columns. Maybe we want to explicitly specify that we do not want any index column to be created. In that case, what we can say is simply index underscore call is equal to none. And here you can see that no index column has been specified. Now, instead of making this as none, we can also say false, and it will generate the same results. Now, when the data frame reads this data from the CSV, let's see what data type it interprets all these columns as. So to check the data types, I can simply type df.dtypes, and it will tell you that it interpreted the customer ID as an int 64, the first name and last name as object, which means strings, and so on. So let's say now when we want to read this file, we want to convert or read the customer ID not as an integer 64 but as a float column. So that can also be done using the read CSV command itself. So the syntax for that is that after your read command, you use the option dtype is equal to, then you have to use curly brackets and you have to say the column name, so customer ID, use a colon, again within quotes write the data type that you want, so float 32, and okay, and let's run this command. And now let's print the data types again. So you can see that the customer ID now has been read as a float 32 column. So you have to keep this syntax in mind to do that. Now in the next scenario, there may be a requirement that we want to read some particular column as the index column. So in that case, what we can do is we can specify index underscore column. So let's say we want to read the first column as index column. So I'm going to say 0 because 0 is how the numbering starts in Python. So I'm going to say index column is equal to 0. And now you will see that there's no explicit index column generated like 0, 1, 2, 3 over here. The first column itself has been treated as an index column. Now let's say there's a scenario in which you want to specify some specific value to be read as a missing value. So there might be empty strings in your data, or there might be zeros in your data which you want to treat as missing values. There might be just strings with just spaces in them which you want to treat as missing values. So that can be done as well. Now in our case, since we do not have any such data, I'm going to specify a particular string. So I'm just going to say that whenever it is a 1, the integer number 1, then treat it as a missing value. So for that, what we can do is simply use NA underscore values and then specify that value that you want to treat as a missing value, and that value will be read as an NaN. So NA underscore values equal to, within square brackets you can give your value. So I'm just going to say 1.0 because this is an integer that I want to treat as a missing value. And running the printf again, you will see that 1 has been treated as an NaN in my case. So it has been treated as a missing value. Now in the next scenario, I want to read all the data in my file except the last 2 rows. So maybe there's a footer record in your data which you do not want to read. So I'm going to skip the last 2 rows in my file and read the remaining data. How that can be done is, again, you have an option called skip footer, and you can define how many rows you want to skip. So let's say we want to skip 2 rows. I'm going to run this right here, and you will see that there's some kind of error, the message that you see over here, and it says falling back to the Python engine because the C engine does not support skip footer. So what we have to do to avoid this warning is simply to add the engine as Python. So here, going back, I'm going to add another option called engine equal to Python, and then I'm going to try to run this command again. And once I do that, there will be no error. Printing my data frame again, you will see that the last 2 records have been skipped. So you can see that the first 2 records are there, William and Janet, you can see are there, but the last 2 records have been skipped. So you can use the skip footer as well to skip the footer records. Now let's say you want to skip some records from the top, or some specific records you want to skip. So we can use the skip rows command. We have used it previously, if you remember, to skip the header record. Now I'm just going to use the different options, the skip rows command itself that you can use. So if you just say skip rows is equal to, let's say 2. So I'm going to skip 2 rows from the top. Let's see how this works. So okay, no errors. I'm just going to print my data frame again. And you can see that the first 2 records have been skipped. Now if you see over here, you got 3 data records still because it has skipped the first 2 records, considering that the first record in a file is a data record, and it has treated it has skipped the first 2 records, then the next record it has treated as a header record, and then the other 2 records, the next 2 records, it has treated as a data record. So you have to be careful with these things, whether the header is there or not. You can combine these different options to read your file perfectly the way you want it to be read. Now we were exploring the options with skip rows. So if you just say skip rows 2, you see that the first 2 records have been skipped. Now you can also specify by the index. So you can say skip, instead of skipping the first 2 rows in this way, what I want is I want to skip the first record and the second record. So if you run this command, let's see what are the results. So here you will see that the first 2 data records have been skipped because the very first record, it will be treated as the 0 index value. So when you say 1 and 2, it is going to skip the records, the data records with the index values of 1 and 2, which are going to be actual data records. Now let's just change it to 1 and 3 and see what happens. I'm just going to run this again. And now you can see that it is skipped the record. So it is skipping the records by the index. If you just give the particular number of indexes separated by a comma, it is going to skip those records by the index. Now instead of doing all this, maybe you just want to skip a range of records. So you can also use the range option right here. So for using the range option, what you need to see is simply say range. So you'll see that it will skip the records starting from index number 1 till the 3rd record. So 3rd record is exclusive. You can see the 3rd record still there. So it has skipped in effect the record 1 and record 2 from the data. So this is how the range option can also be used with skip rows. Now for the next scenario, I have created another file. I have just copied the same file and I have just changed the separator in the file to a pipe. So there might be many scenarios in which your separator is not an actual comma, but there is a different kind of separator. So in those cases, you can use the option of separator. So SCP equal to, and then define the separator that you have in the file or the delimiter that you have in the file. So in our case, it's a pipe. So I'm going to define it as a pipe, and I am going to change the name of my file to customers underscore pipe. Printing the data frame again, you will see that it has been able to read that data as well. So you can just define your separator using the SCP option over here, and it will be able to read the file with a different kind of separator as well. So in a similar kind of scenario, maybe now you just want to read the first n rows from your data file. So you can also use the skip rows. There are various options that can be used with skip rows, but there's another option that can be used, and that is called n rows. So you can define the number of rows you want to read from the top. I'm going to define 3 rows that I want to read from the top. Just going to run this and print my data frame, and you will see that it has read the first 3 records. It has skipped the 4th record in the data. So it's a very simple to use, simple, straightforward option. If you just want to read the first 100 rows or something like that, you can use this option. Now let's say that there's a scenario in which you want to use your second row as header. So that is your header record. You want to treat that as a header record. So how can that be done is using the option header again and then specifying the second row. So second row by index number would be 1. That is what we are going to specify here. And you will see that the second row, which is the first row, first actual data row in our case, has been read as a header record. So it has actually skipped the other rows, the previous rows, and it has read this first row as the header row. Now let's just say and try to check if we say third row is header, then what it does. You'll see that all the other previous records have been skipped, and it has read the third row as a header and only read the rows after that as the data rows. Now I'm thinking of some more scenario. Maybe there is a need for you to read all the columns as string from your CSV file and not let Python interpret the data type on its own. So simple way of doing that is again using the dtype option that we have seen earlier, and simply say dtype is equal to str. And you will see all the 3 columns have been read as object. Object in Python means a string. These were the different examples using the read CSV command in Python, and I hope that you found this video useful. I've put all these commands down and I have provided the link below in which you can access all these commands and practice on your own. I hope that the video was useful. If it was, then please do not forget to subscribe to our YouTube channel, and if you want any more videos on pandas on any different topics, please let us know in the comments below and we will be posting more videos soon. Thanks a lot for watching. Goodbye.